we've talked about factoring. Whenever we looked at polynomials and broke them down, like for example, x squared plus 4x plus 4. We broke it down by saying a and b have to add up to 4 and multiply to 4. Now we know that that would be 2 and 2, giving us x plus 2 times x plus 2. But what happens if it's not so easy to factor them like that? What can we do in a more general case? Well, we know that if we have x plus a squared is x squared plus 2ax plus a squared. So if we have something along the lines of x squared plus 6x equals -5, then by looking at this as an x squared plus 2ax, we can sub in the constant a by just adding something. So we know that since x squared plus 6x, since this 6 right here is 2 times 3, we can look at this as x plus 3 squared, but this is x squared plus 6x plus 3 squared, which is 9, so we take that 9 away, minus 9 equals -5. Well, we can now move the -9 over to the other side to get x plus 3 squared equals 4. And now, all we need to do is take the square root of both sides. So, finally, this is just to make some more room on the board. X plus 3 equals the positive or negative square root of 4, which is 2. So we can solve for that to get x is -1, because -1 plus 3 is 2. Or x is -5, because -5 plus 3 is -2. Then, if we actually put this back together to the x squared plus 6x plus 5 is 0, we would get x plus 5 times x plus 1, which multiplies into, I'll write this out here, and if we set that equal to 0, then either this must be 0, in which case x is -5, or this must be 0, in which case x is -1. So, the act of doing all of this shenaniganry is called completing the square. And the way we do that is by saying x squared plus, pick a number, you could call it ax, but let's do another example because the ax example is right here. X squared plus, let's say 5x plus 4 equals 11. I don't know what this is all going to end up equaling, but let's go ahead and say x squared plus 5x can be a part of, since 5 is 2 times 2.5, we've got x plus 5 over 2 squared, and then 5 over 2 squared, which is going to be the last term that it gets over here, is 25 over 4, which is 6 1/4. And since this is a plus 4, this is like plus 6 1/4 minus 2 1/4. So this minus 2¼ equals 11. So x plus 5/2 squared is 13¼ So now all we need to do is take the square root of both sides. This is really the same thing as 53/4. So we've got x plus 5/2 squared equals 53/4. So x plus 5/2 equals plus or minus the square root of 53/4, which is equal to plus or minus the square root of 53/2. Notice right here that it goes from a 4 under the radical sign to a 2 not under the square root sign. By the way, those square root is called a radical. Radical is square root. Comes from the same word. Following this a little bit further, we now get x equals plus or minus, well, I'll start with the known value first. So x is, if we move this over to the right, negative 5/2 plus or minus the square root of 53 divided by 2. And this may look like an unsatisfying answer, but if you actually went in and multiplied that all together, you would find that those, in fact, are the values that you multiply together to get the expression, hold on, where did we start a moment ago? X squared plus 5x plus 4 equals 11. Or, if we move the 11 over, x squared plus 5x minus 7 equals 0. Those are the values that you would get.